Right. Well, let me try a test number 2 here. So here we have the learning targets, and you should have already mastered number 1. Number 2, we're going to talk about exothermic and endothermic, and I think you've really understood it. If you can tell me 5 differences between them, you can imagine a future quiz coming on that. So the first thing is that exothermic reactions. Here's a definition. This is a process or a reaction that give off heat. Now, I sometimes use the word heat, sometimes we use the word energy, and heat is the most common form of energy, but it's a process that gives off energy. So if you hear a bang, you see light giving off, that would be exothermic. You set something on fire, you could feel heat given off. I remember this by the X in exothermic. Kind of reminds me of the word exit, and that is heat exiting the system. So the system is whatever you decide is what you're focusing on. So when energy goes from inside the system and is moved to outside the system, that we call that the surroundings. That is called an exothermic reaction. Opposite is endothermic reaction. This is a process or reactions that absorb energy or heat has to be put in or added. I remember this by the word N in endothermic, reminds me of the word in, like it spells with an N. So heat is entering into the system. So if there's heat that was in the outside surroundings and it went into the system, we call that an endothermic process. So here's a question for you, exothermic or endothermic? What if you're warming up some water to make some ramen noodles or some mac and cheese? Is that exothermic or endothermic? Well, it's kind of a trick question because it could be either. If you decide that the system is the water, well, heat is going into the water and it's absorbing energy. And so the water would be endothermic or endothermic. But if you're talking about the appliance, the stove, whether it's a gas or electric, that the appliance is giving off heat. And so from the appliance's point of view, that's an exothermic reaction. From the pot of water's point of view, that would be an endothermic reaction. So watch out for that. So some examples is that exothermic reactions tend to get hot because the chemicals have storing energy and they give off some energy and warms up the area, adjacent to it. So if you were to put chemicals inside of a beaker or a test tube and you felt the test tube and the test tube got hot, that would be exothermic. The chemicals, the heat energy used to be inside the chemicals and the energy went into the surroundings. The test tube would be part of the surroundings, and when your hand touches it, your hand's part of the surroundings. And your hand gets hot. Freezing or condensing are exothermic reactions. Believe it or not, freezing gives off heat. All right. It's kind of a strange thing, but so does condensation. They actually give off heat when those occur. You might think freezing is cold. Well, that's a cold temperature, but freezing gives off heat. Remember, temperature and heat are not the same thing. More on that in a second. Well, here it is. In the South, on like a citrus farm, if there's like a frost or freeze warning that could damage the crops, they'll sometimes turn on their sprinklers. And as the water's on and the temperature drops low, it becomes a shield of ice, a coating of ice. And sometimes students will think, that kind of protects it, like an igloo protects an Eskimo. But the answer that relates to exothermic reactions is this: as water freezes, it gives off heat. So as the water outside the orange is freezing, it gives off heat. Some of the heat will go into the air. Some of the heat, though, will go into the orange. And that heat going into the orange does not actually maybe warm up the temperature, give it a little bit more warmth. Okay. Now we can't do this in Michigan so much. Like we have a frost freeze warning recently, but because we're worried about the cherry and apple and the fruit blossoms, and if the delicate flower gets covered with a coating of ice, that would destroy the crop, not a hardy, mature orange or grapefruit or something like in the South. So endothermic, on the other hand, are substances that might get cold. If you do a reaction and it feels cold, an endothermic reaction are like those cold packs that like athletic trainers carry. You mix up some chemicals, it gets super cold. You could put that on, a swollen ankle or something like that. So that's because heat is going from the surroundings into the chemical bonds. So, do you have to add heat to like melt butter in the kitchen or to boil some water? You certainly have to add heat. Those are endothermic reactions. All right. Another difference is there's a thing called delta H. Now, this really means like a change in heat. It's a fancy word called enthalpy, but we'll just call it change of heat for this year. And if you ever have a negative value, that's exothermic. I think again is the heat's exiting, so it's going away, and that's showed with a negative value. So if you saw like the delta H is -5 kilojoules, that would be exothermic. And there's these famous graphs that come with exothermic and endothermic. And if the graph starts up high, meaning high energy is the reactants, and ends low, meaning the products are lower in energy, the drop is the delta H. And if the drop goes down, that's negative. The opposite of endothermic is delta H is a positive value. And the famous graph has low energy to start with and high energy. This is showing chemical A and B turning into chemical C, and the heat is going up. And so the delta H is positive. Now, this graph has a little bump in it, and we'll talk about that another day. Okay. There are three ways to show heat change in chemical reactions. Remember when we write reactions down on pencil and paper? So here are the three ways to do it. In this case, for calcium, 3 calciums plus a diatomic nitrogen to a Ca3N2. Here are the three ways. The first way is you just off to the side write down the delta H. And if it's 80 kilojoules, you have it. And if it's negative, we put a negative number because negative is exothermic. But another way we can do it is we can just pretend heat is one of like the substances, and we'll write down calcium plus nitrogen turns into calcium nitride and heat. But this does not mean positive. This is using it to separate one substance from another substance. So if you have the word heat on the product side, that's the stuff after the arrow, that's another way to do exothermic. Now, heat is a qualitative measurement. If we want something more exact, a quantitative number, we would replace the word heat with the actual numeric amount of heat. In this case here, 80 kilojoules. Again, this is not positive 80 kilojoules. This is plus. This means and 80 kilojoules. And we put these on the product side, that's exothermic. Look at the next slide. An endothermic reaction, we take water and oxygen, add some energy, you can make water. I don't know if that's true. Anyways, we get this number here, here, and here. Okay. So here's a slide that summarizes all those. You can maybe keep this slide up when you want to do your homework. Okay. And was that the end? All right. Boom. Done. How do I stop casting? I don't know how to hit stop. Oh, no. I don't know what I just did. Shit, what am I doing? Hey, there we go.